Right now, as you watch this sentence, something just screamed across the universe. A burst of radio energy so powerful it released more energy in a millisecond than our sun produces in 3 days. And it's not rare. This is happening thousands of times every single day from every direction in the sky. We've been detecting them for less than 20 years. We still don't fully understand what creates them. And the most unsettling part, some of them repeat, not randomly, in patterns. What in the universe is powerful enough to do this, survive, and do it again? In 2007, astronomer Duncan Lorimer was reviewing old data from the park's telescope in Australia. He wasn't looking for anything revolutionary, just routine pulsar observations. But buried in the noise was a signal so intense, so brief it looked like a glitch. A single spike lasting 5 milliseconds, then nothing. Imagine hearing a thunderclap from a storm that doesn't exist. That's what this was. A cosmic shout with no source. For years, scientists debated whether it was even real. Some thought it was terrestrial interference, microwave ovens, satellite signals, anything but something genuinely cosmic. Then they found another one, and another, coming from completely different parts of the sky. These weren't errors. They were coming from billions of light years away. The energy required to produce a signal detectable across that distance is almost incomprehensible. We're talking about something releasing the equivalent of 500 million suns in the time it takes you to blink. But here's where it gets strange. In 2016, one of them repeated. Fast radio bursts shouldn't repeat. That was the assumption. Any event powerful enough to create one should destroy its source. Like a bomb, you only get to explode once. So repeaters broke everything we thought we understood. Let me explain what we think is happening. Picture a neutron star. The collapsed core of a dead star, about 12 miles across. It contains more mass than our sun, crushed into something the size of a city. Now make it magnetic, not like a refrigerator magnet. A magnetar's magnetic field is a quadrillion times stronger than Earth's. If you got within 1,000 miles, the field would scramble every atom in your body. Here's the number that changes everything. A magnetar's magnetic field stores enough energy to power human civilization for 1 billion years. When that field suddenly rearranges, when the crust cracks or magnetic lines snap, it releases energy in milliseconds. And in 2020, we caught one in our own galaxy doing exactly this. SGR 1935 plus 2154 fired off an FRB while we were watching. First confirmed source, which leads to the part that most people never hear about. Magnetars can't explain all of them. Some fast radio bursts come from regions with no magnetars. Some show patterns that repeat every 16 days, then go silent for months. One repeats every 157 days with clockwork precision. That's not a random stellar tantrum. That's something orbiting, or pulsing, or alive in ways our physics hasn't imagined. Here's what keeps researchers awake at night. FRBs might be the most powerful tool we've ever discovered for mapping the invisible universe. As these signals travel billions of light years, they pass through everything between us and their source. Intergalactic gas, dark matter halos, the cosmic web itself. Each encounter leaves a fingerprint on the signal. By studying how FRBs arrive slightly smeared, slightly delayed at different frequencies, we can weigh the universe. We can count every electron between galaxies. In 2020, FRB measurements helped solve a 20-year mystery, the missing baryon problem. Half the normal matter in the universe was unaccounted for. FRBs found it hiding in the spaces between galaxies. These millisecond screams are X-rays of the cosmos, and we're only beginning to read them. So the real question is, does this change what we think is possible? Right now, in British Columbia, a telescope that looks like a half-pipe skate park is revolutionizing this field. CHIME, the Canadian Hydrogen Intensity Mapping Experiment, detects multiple FRBs every single day. Before CHIME, we knew of about 50. Now we've cataloged thousands, and the data is overwhelming. Teams are working around the clock, developing AI systems to classify bursts faster than humans can process them. In Australia, the ASKAP array is pinpointing FRB locations with unprecedented precision. In China, the FAST telescope, the largest filled aperture dish ever built, is catching the faintest signals. A new FRB catalog just released contains over 500 new sources. Each one is a potential laboratory for physics we can't recreate on Earth. The race isn't just academic. Understanding FRBs means understanding extreme magnetism, relativistic plasma, maybe even physics beyond the standard model. Someone reading a printout right now might be holding the answer. Somewhere right now, something just screamed across the universe. A millisecond flash from a dead star's magnetic convulsion, or something we haven't named yet. By the time you finish this sentence, it's already happened again and again. The cosmos isn't silent, it never was, we just didn't have ears to hear it. Now we do, and every signal is a question waiting to be understood. So here's what I want to know from you. Do you think FRBs will turn out to be purely natural phenomena, or will we find something in the patterns we can't explain? Let me know in the comments. Follow for more, we post every week.